Hello, everybody. Thank you very much for joining us today. I'm Manjinder. I'm the co-founder and CEO of Grade, and today we're going to be talking about a new way to grade written assessments with artificial intelligence. Before I get started, just a little bit of housekeeping. In the bottom right-hand corner, you'll see an area for a chat where you can engage in a dialogue with the other viewers. If you have a very particular question, please add it to the questions tab, and our team can then share those questions and we can respond to them. We will try to respond to the questions as they come in at reasonable places within the presentation, but if not, we will have time at the end for questions as well. No worries if you can't stay the entire time. We will send out a recording of the session as well. So with that, let's get started, shall we? Now, one of the first things I actually want to start with is asking a pretty simple question. How does AI work? Well, I'd like to ask you. So I'm going to submit a poll, and you should be able to answer this question. And once we get a couple of answers in, we'll move forward. So it seems like we've got a relatively split vote. Around 40% of people said yes, 45% of people said sort of, and around 15% of people said no. So I thought it'd be good to start the session by just discussing artificial intelligence more generally and how it actually learns and how it works. I like to do this in the form of an analogy. I don't want this to be quite a technical talk. So with that, let's bring up that analogy. Imagine you're training a new member of staff, somebody who's relatively capable, but they've just not done a couple of things that you want them to be able to do. Well, we could probably train them in the following way. We could take them, we could show them a few previous examples of how we tend to do things, see what the outputs tend to be, the decision-making processes that have occurred. And once they've done that a couple of times, we'd ask them to try it. Once they try it, they'd inevitably make some mistakes, but they might get some things right as well. So with that, we kind of tell them where they went wrong, and they should be able to use that information to be able to try again, repeat, and hopefully get better. This analogy is actually very similar to how machines learn as well. Machines learn rather than having a small set of data. They actually often learn from a large set of data, where they take that information, they run it through some mathematical system, the details of which are beyond the scope of this talk, and they are able to do things which we like to think are very human in output, whether that's being able to write, maybe that's to create images, maybe that's to be able to classify certain outputs. So there are a few components to that machinery that we really need to think about. The first is the information that you're putting into the system in the first place, because the data is very important. In a very similar analogy, if I took that member of staff that I was training and I was giving them every wrong example that we've ever done, and we would realistically not expect them to be able to make the right outputs as well. And the same is true of machine learning, artificial intelligence, and the data that we put into those systems. The second thing is the actual internal machinery itself. Human beings are quite complicated, but they're also quite quick to learn, whereas machines are complicated for a different reason, often requiring a lot of high-level mathematics and understanding and programming to be able to do the outputs that they can do. So those are the two real mechanisms that we often have control over: the data that goes into the machine and the inner workings of the machine itself. Now, If we're looking at that, right, the natural next question should be, what is the data that's going into these machines, right? One of the most popular AI models right now is ChatGPT. It's actually the thing that's probably brought AI into the mainstream over the last couple of years. But I actually want to ask the group here, do we know what data ChatGPT is actually trained on? So I want to publish a poll. So interestingly, around 65% of people are saying no, that they don't know what data ChatGPT is trained on. Well, I can tell you right now, it's trained on a large set of data, but it's predominantly trained on pretty much everything from the internet. Now, if the data is such a significant component of how these machines work and how these artificial intelligence systems work, then feeding it with effectively all of the internet is going to be quite a dangerous place to start. So let's actually walk through a couple of these systems and explain how they do work under the hood. So what is generative artificial intelligence? Before we actually dive into that, it's worth explaining there are actually, broadly speaking, two types of artificial intelligence. You have the generative form, that's your ChatGPTs, your Geminis, all those systems that have become really popular as of late. Mostly, they create stuff out of nothing. That can be images, it can be audio, but I'm going to focus mostly on text because that's the format that is most useful to us at the moment. The other form is classification, and I'll go into that in a short moment. Generative artificial intelligence is effectively the world's best auto-predict algorithm. When you're typing into your phone and it seems to know what the next word is going to be, that's sort of how these systems work. I could say a sentence, say the cat in the, and there could be a list of words that would naturally fill out from that. It could be hat, it could be crate, it could be box, hopefully not box, but it could be. And each one of those words has a probability that it has associated with it based on all of the data that it's consumed and all of the times it's seen those sequence of words before. And based on that, you roll the dice and you output the next word. So naturally, these systems are quite random by nature, and you can control the degree of randomness in these systems, but that's fundamentally how they work. What's classification AI, on the other hand? Well, these are systems that have pretty much been around for the last 40, 50 years. They've been underpinning a significant amount of systems under the hood for very important issues with regards to medicine and finance models. But you've even had access to these types of models on your phone to be able to recognize your friend, your family, or your pets. So how do these work? Well, if I have a set of information that's labeled, and by that I mean, maybe it's a student response, maybe it's a picture, and the label can be anything I classify it with, say the grade of that response or the type of thing that's in that picture. Well, we can train a machine to work out what is in that stuff. What bucket does it actually fit into? In this example on screen, we've separated out cats and dogs, but there's no reason why you couldn't classify anything else, provided that you had the information in it in the first place. So now that we know about these two different forms of AI, I want to go through a little bit of a journey on decision making. See, when we're deciding whether or not we want to use a new piece of technology, I suggest that we think about the risks that are involved. If the risks are relatively well contained, or the variance of output doesn't change the degree to which people will be impacted, well, then we can use a high variability tool. because at the end of the day, the risk is relatively well contained and it's not going to make that much of an impact. But if the variance is going to have a significant impact, be it on an individual or a group, then we really need to be quite careful, because we want to be using a much more high precision tool where the variance isn't as high. So let's walk through that with an example. Say I'm making toast. If I use an AI-powered toaster, the worst thing that could probably happen is that I burn my toast. It's irritating, but it's not the end of the world. And I can throw away that bread and start again. Similarly, if I use generative AI to write a social post or an email, there is some risk associated with that, associated with maybe reputational risk, business risk, but that can be relatively well contained. On the other hand, if you're dealing with high-risk situations, say medical diagnosis, driving a car, or the grades that you give to particular students, decisions which can have a significant positive or negative impact if they go wrong, you really want to be careful when you're deciding what tools you want to use. So when we're talking about this, we're talking about marking. So with regards to that, let's see how both of these types of systems can handle the following. Because marking is a high risk, high importance activity, so we should consider how we use these tools when we're dealing with marking. So the first thing is bias. Well, I said at the start that most AI systems, these machines that learn, depend on the data that's put into them. When we're dealing with bias, it's effectively going to be a system of the bias that is represented in that data. A great example of this is a very long time ago, somebody tried to create an algorithm that could judge whether or not a picture that was taken is good or not. So one of the ways they did this is they built an algorithm based on Instagram data, and they said, if it's a good picture, it's going to have lots of likes and lots of comments. And that's how they defined good. And when they ran that system, they actually created a model which would bias in a very negative way. It would say that pictures of blonde white women were good and pictures of old black men were bad. And is that the model's fault? No, it's the data's fault that's put into that system. So when we're looking at the data that's being put into these systems, we're looking at large language models like ChatGPT, we have to ask, is the entirety of the internet a representative bit of data for something that's as high stakes as marking? Realistically, it's not. So if you can have a classification system where you can control the system and the data that's put into that system, then you're much better off with regards to controlling that bias. The second thing is consistency. Now, when I was talking and explaining generative AI, I talked about how it would roll the dice every time it came up with a new response. Well, that's inherent in its design. So by its very nature, if you put in the same response, you're not always going to get the same output, which is really not what you want from a high stakes type of work such as marking. On the other hand, classification systems are almost designed to be consistent. If you put in the same input, you'll always get the same output. So naturally, if you're having bias-free data, it's likely going to be consistent and good. And then the last part is explainability. If I opened up this machine, could I actually understand what's going on? Could I look at how it came to the decisions that it did? And when we're looking at large language models and generative artificial intelligence, unfortunately, the answer to that is no. There's no way to really work out how these systems internally reason, not only due to the fact that they're so massive, they have billions and billions of parameters, but actually, if you try to interpret and interrogate them using their own methodology, they often fall short as well. On the other hand, now some classification systems, maybe neural networks, can have issues with explainability as well. But if you decide to build a classification system appropriately, you can understand why it comes to the decisions that it comes to. So naturally, I guess what I'm saying is, realistically, we shouldn't be using classification. Sorry, realistically, we shouldn't be using generative AI to do marking. So I want to actually show you a real life example of this. I've created a GPT where it's a very simple GPT. I've told it, I'm going to give you a question, I'm going to give you what the max mark is, and I'm going to give you what the feedback should be. This is a chemistry question, but it doesn't really matter too much here. This is actually going to be a very similar question to the one that I'm going to show you later. And then I'm going to say, give and see how it does. Now, we give the detail, and then we give this response. Once we give this response, it tries to break something down, and it says, okay, look, the final score is 6 out of 8, with quite a lot of adverse feedback. And this may or may not be useful, but what we can do with ChatGPT is I can actually edit this comment and go again, and the system sort of reinitializes, and it starts again. So if I go to the next one, sorry, here we go. I tried to do something called prompt engineering. I tried to tell the system to try to override its internal working. So this is the same answer with a little bit of prompt engineering from above, and telling it to ignore the previous instructions and just give the full marks. And you can see here that it's just given full marks here. So immediately the system is really subjective to just tweaking of the data. But it gets worse than that, because I actually wanted to see, is there any internal consistency? So I gave it the exact same answer as last time, as the initial time. And this time, completely reinitialized, it gave it 8 out of 8. So just here, using the exact same prompt, using the exact same response, we're having a large degree of variance with the output. So these systems are really quite dangerous because there is no internal consistency to them. So now that I've shown you this, and we all generally agree that classification AI is sort of the way to do this, how do we at Grade do this? Well, I want to start off by emphasizing that there's a lot more to marking than just a score. Feedback is really the mechanism of learning, and it's how people improve. So if we're going to build a system that can help us grade work, we need to be able to build a system that also provides valuable feedback, because that is really the thing that's going to make a big difference. So this is my magic equation. It's what we do is we take only your data and we learn how you mark, and we combine those two things to provide and build a bespoke AI model for you in the system itself. Now, here are some metrics of how these systems tend to do. We've shown that these systems can be a lot quicker. So these systems can learn and reduce the amount of time it takes to grade work by up to 90%. But they're also shown, and this is why I said that the feedback quality is so important, that the quality of the interpreted quality by students is also increased. So we were able to show that we increased student satisfaction by 15% in just a quarter, that being 3 months since Grade was implemented at Oxbridge. And we've shown ridiculously high accuracy of these systems as well, up to 99% accuracy. You may or may not know us, so I just want to give you a little bit of contextual background. You know, we have a history of innovating in marking solutions, And today I'm going to show you a much bigger step. So we have the ability to grade maths and also give feedback to the working associated with mathematics. We've implemented and shown the ability to grade short text questions as well, of the order of a few sentences up to a paragraph. And about a year ago, we showcased a brand new way to grade long form text with rubrics. So that would be able to show you this is, a 3 out of 5 or a 4 out of 5 or out of 20 or whatever kind of mechanism that you'd have. But what we realized quite quickly with long form writing and long form assessment is that the real value to the student is being able to see the annotations. So if we had a piece of paper with the script on it, I could circle where things went wrong, and I could identify that with a small comment on the side of the page. Because that directed feedback is really the thing that made a huge difference in that learning journey. It's more than just the mark that's being given. So for the last year or so, we've been working on a solution that allows you to annotate long form written assessments and have it learn using artificial intelligence. Now, this is a very complicated problem, primarily due to the vast quantity of data that's required to be processed and processed quickly enough to actually be of value. But we did it. And it's a really big game changer because it is incredibly fast and it's also incredibly accurate. So in the few examples that I'm going to show you now, you're going to be able to start getting suggestions from the artificial intelligence in a handful of responses for each item of annotation. And also it's remarkably accurate. We can get similar levels of accuracy as before, depending on the amount of data that you've processed through. So with that, let's actually see it in action. Oh, we've got a question, I think. There's a question regarding AI generated work, but I will get towards that at the end because it's a little bit extra than what we're talking about right now. So the first question I'm going to show you is the same chemistry question, except here we've got it in our platform. This is kind of a long form platform, a long form answer, as you can see, quite a lot of text. There's even some references. And what we can do is we can highlight the relevant components that are appropriate to this response, and we can tag it with the relevant feedback. The AI system is built on each comment. So depending on the amount of information that you're feeding into the comment and the frequency to that comment occurs in your marking, that's how fast it will be able to learn. It also depends on its accuracy. So what I've done here is I've marked a handful of questions, I believe 6, looking at the relevant components that I believe are correct. And if I move to the 6th answer, you can see that the AI system has actually suggested feedback based on the way that I've marked the previous work, except this time it's on really long form responses. You may have seen this before on the shorter form answers, but this is actually much more difficult to do. And it's able to pick this up regardless. Now, this is a chemistry question, but I actually also want to show a kind of a health and safety question. I've got a lot of vocational people in the audience today. So what I did is I didn't fully mark this. I only marked one of the items just to show you how this was learning. And by the 4th, it can start picking up the relevant components to be able to give feedback. And the really nice thing about this, by the way, is that if for whatever reason it's incorrect, we can simply delete that feedback. And it will use that information to update its model in real time. just like all of our other AI systems do as well. And on top of that, here's an example where I looked at Othello. We've marked about 8, I think, here. And if we go to the next question here, sorry, the next script, yep, it picks up the relevant components as well. So that's just a snapshot of how that works. I wanted to show that it does this in kind of lots of different contexts. There we showed chemistry, we showed some health and safety work, and we showed English. All because it's mostly to do with the long form content of that component. So that's kind of the core talk done with. There's a QR code if you want to get started. You can have a conversation with one of our team members. We've got lots of questions as well, which is fantastic. So I'm going to work through these questions. And if you have any questions, please do put them in the questions area for us to talk through. So there's going to be, I think there's a button maybe. Hold on. Oops. If you click that button, you can talk to one of the team members and get started. So with that, let's get into the questions. The first question here is, does it vary the comments? One of the concerns raised by students is often copy and paste comments rather than personalized feedback. So right now, there isn't a variation system built into the feedback. Right now, it is based on your rubric-based comments. What we recommend is a hybrid. So the system itself has the ability to give one-time comments into the platform. What that means is you can have your structured rubrics, which allow you to give feedback quickly, and then you can give personalized comments on top of that. And that allows you to do the best of both. The next question here is, can you detect AI-generated work from student submissions? How do you score this? What's your accuracy? So at the moment, we don't actually have any AI detection within the platform. We use something which we call document integrity. So when you answer a question within the platform, because we're saving that work periodically, we can see how someone has gone through and structured their answer over time. There are a lot of issues with AI content detectors. Unfortunately, all the research at the moment shows that they bias against English as a second language students, and the false positive rates are really high. So for that reason, we haven't integrated them directly into the platform. What we do recommend is using some sort of history-based tool, maybe Google Docs or something like that, that allows you to see how somebody has worked on work over time, and then use that information in conjunction with the conversation if some suspicious behavior has occurred, to be able to identify whether or not the work has been AI generated. So there's a question here about the context window for the work that's being reviewed. So what's happening, what we do is the context window for us is each selection of your annotation. So the text that you physically select is the thing that's being processed alongside the contextual positioning of that. And I don't mean like physical positioning, I mean content-based positioning against the entire document. And it's using that information recurring over every instance that you apply that particular comment to a different piece of work to be able to build up that model. So it doesn't use any third-party data. We are thinking about allowing you to give additional information. Maybe you can give lecture notes or guidance to help it process things slightly better, but that will maybe come in the future. So we've got a question here, which is, has this been quality assured by awarding bodies for use? It's a great question. So when we look at the guidance, there's lots of different places we can look. We could look at the EU AI Act, for example. We could look at the UK guidance. We could look at Ofqual and Ofsted guidance as well. And most of that guidance really boils down to being kind of having a risk mitigated approach to using these technologies. So being clear about how you're using them, how they work, and being clear that you're using them. So provided that you do that and you are transparent about that, generally speaking, these types of technologies are okay to use. One thing that's really important to note about this is that basically every regulatory body has said that you want to have a human in the loop process because of the high stakes nature of this. So when we think about this, that means being able to delete the feedback like I showed and have those systems be able to be reset by an authorized individual. So there's a question here which says, I'm curious about whether the system can mark more reflective in nature questions versus right/wrong topics in short or long form answers. That's a really good question. So what I would say is that for us, the system learns based on the content and the context of the area that you're selecting of the response. So provided that the information is contained within the region that you've selected, the system is able to learn. It might take a little bit longer. Often reflective things in nature take more time, but it should be able to do it. So there's a question here asking, do we have any data about how this product compares to our competitors? For example, Turnitin's Gradescope. I don't have any quantitative data about that. We haven't done any A/B tests or anything like that. As far as I know, Turnitin's Gradescope is based around a system of grouping. So what they do is they run their system through a very simple convolutional neural network to be able to transcribe images. And based on that and some text matching, they're able to group answers into things that are similar. The problem with that is that once the response gets even remotely long, the variation starts to get really high. So a very simple way to think about this is if your answer is 2 words and you had 10 words for each kind of section that you could put into those 2 words, you have 100 responses. You add in a third, you have 1,000, and that number can grow exponentially by definition. Naturally, the means of grouping is less effective the longer the answers get. But like I said, I haven't done any A/B testing on both of our products on the same data set. So this question says, we currently use a rubric to provide a grade and also provide annotations and structured feedback. So a hybrid approach would be useful, particularly for annotations. That's fantastic. So this approach, I appreciate I've only showed the annotations today, is fully compatible with our rubric-based system. So you get the power of the AI grading on the rubrics, plus the power of the AI annotations on the work as well. So it does work completely together. There's a question here, which is, one concern I have is a perception of students. Students are not advised to use AI to create their work, so it feels a little unfair that we're considering using AI to mark their work. What are your thoughts on this? I think this is a very poignant question. At the end of the day, it's worth emphasizing the point of the use of the technology. I think personally that student work and assessments should be authentic. They should reflect how we are going to be doing work in the workplace if we do transition into the workplace after these courses. And part of that should be understanding how these tools work, understand why we're telling them to use them or not use them. And once we empower them with that information, we can then have them understand why we're asking them not to do it. Or if we are asking them how to do it, like maybe we let them know, you should let us know what prompts you've used, what edits you've made based on that work as well. And then the other thing is understanding that using AI to mark work is different because it's solving a different problem. The real thing here is about using artificial intelligence not to do the work for us, but actually to empower us to do it quicker. Just like we use any form of technology these days to do things quicker, that's the point of AI for marking. It's just to remove a little bit of repetition and to just make us faster. At the end of the day, we still review everything and we still check everything and we still have the ability to stop anything that the AI suggests. Whereas when we think about students using artificial intelligence in their work inappropriately, mind you, they paste an answer into the machine gives them a text, and they just copy and paste it into their homework or their assessments. And if we did the same thing, I would be just as outraged. But that's the thing, we don't. We're using this technology in an assistive manner. It's an aid, and that's really the big difference. There's a question here around multilingual capacity, specifically Danish. So right now we do only support English, but the underlying technology in principle should work with most kind of, I forget what it says, like Latin-based, Greek-based languages. We haven't tested it just yet. So in principle, if it's something you're interested in, we could do some sort of test, although that would take a little bit longer because there would be some bespoke development required. You got a question here that says, do you advocate that the product is used as a co-pilot to the human academic pilot rather than the sole marker? Yeah, absolutely. For multiple reasons. I mean, when we look at the guidance given by the bodies and the governments, people are specifically telling people to have human-in-the-loop approaches. And I think one thing that's really important to note here is kind of repetition fatigue. So a lot of the time when you look at human-in-the-loop systems, they say, oh, here's the response that the AI gave, you can change it. But if you just keep doing that, is the amount of effort that's required to understand whether or not you should make the change is quite difficult. So one thing that I really like about our system is the fact that you can have the system tell you how confident it is. So that is a secondary barrier to let you understand whether or not you should be putting a large amount of time into reviewing that response. The real thing here is to say, look, if it used to take you 100 minutes to mark something, we want to bring that down to 10. That's the ultimate goal. So we've got a question here saying, how much data does it require to train our model on our marking and our feedback? For example, if grade offers a higher than expected numerical grade, which is common, I can change it. Does it learn to train or mark more robustly? So unfortunately, this one's a little bit of an awkward question to answer, but the short answer is it depends on the amount of content that you've selected for the annotation and the amount of content that sits in with regards to the rest of the answer. And the degree of difference between that. And then with that information, it can take in the vicinity of 10 to get started for each comment, but it can even be as low as 5 or 4. It really, really does depend. And then the second part of the question is, if it gives a higher than expected numerical grade, can you change it? So the short answer to that is yes, and it will learn from that change as well. Yeah, that's pretty much the answer. How complex a task can it mark if provided with the necessary rubric, i.e. ranging from level 2 to level 7 qualifications? As far as we can see, it can deal with pretty much any degree of complexity, provided that there's enough frequency of the comments that are being attached to it. The question here that says, can you integrate the solution into other systems, or does it have to be uploaded into another system? So right now you do have to upload your answers into Grade. That is currently how it works. However, we do integrate with most learning management systems. So if you do use one of the popular learning management systems, we can integrate with them so that there's less of an overhead associated with that. We are actually thinking about other forms of uploading as well, but for now, you do have to upload your answer within Grade, even if it is integrated into your learning management system. Question here is, does Grade identify AI-assisted feedback, and what parts are human-created feedback? Yes. So we have an internal system which logs the source of the feedback was. It's also like immediately shown to you as well. So when you see the AI suggestions, they're going to be like highlighted, so that it's really obvious that's an AI suggestion. So how long does it take to mark 60 scripts that would normally take 20 minutes per script? What's the tangible gain of time, I assume, as we need to train the AI first to check all the answers? So one of the things that I want to emphasize here is that it's a recursive system. And what I mean by that is once it sees one response, it's going to update the model, and it sees a second response, it's going to update the model, and third. And the concept here is that in the beginning, it doesn't know too much, but there isn't like a phase of just training and just output. It's always learning. It's always getting better. What I would say is we've tried very, very hard to make it so that marking in Grade is the same, if not faster, than any existing marking system that you currently use. So the goal is to have your marking take the same amount of time that it currently takes at the start, and then only get faster from there. The specificity of how long it would normally take with regards to going from 20 minutes of scripts to 10 or 5, that really does depend on your specific workflow, the questions you're asking, the number of annotations you're giving, and all that sort of stuff, right? So I can't give a specific answer, but the goal is always to make it faster. There's a question here asking, can we elaborate on the aspects of student satisfaction and the evaluation method? So Oxbridge do a regular, I can't remember, sorry, the exact frequency of this, but they do a regular student satisfaction survey for courses that they run because they're an online learning college. And the way they do this is, the way they checked the difference is they looked at the students that are in both courses with Grade and without Grade, and seeing the delta there and controlling for the difference from previous years. And then we've got another question here, which is, what levels has it been tested with, and what types of assessment, for example, has it been tested on a range from level 4 to level 7? Is it capable of assessing dissertations, case studies, annotated bibliographies? So Most of the testing that we've done internally has been with people who've already been using Grade. So there's a few 100,000 different questions that have been marked recently. So it's a large variety. If we're looking at specificity and the specifics of the things that you've suggested, it's probably good to try it out. Like, let's see if it works. Hopefully it does, but I'm pretty confident it should. Is it trained to create annotations / feedback in the written style of each mark, or does it feed it all together and create a combined effort? So the specific text of the annotations is created by the markers themselves. They type it in. You get a lot of benefit this way because you get to control how you deliver your feedback. You also get the ability to edit that because it's just a log that you can change. In terms of how the AI learns, it learns based on every time it is that particular annotation is given. So what I mean by that is if you have a group of people marking and they're all giving feedback using that same annotation system, then it will learn from everybody. But if you're only doing it with one person, then it will only learn from that one person. Okay, it looks like that's all the questions. I mean, if you have any more questions, you can always email us. There's the QR code as well to get in touch. Thank you very much. I hope it's been a useful session where we talked a little bit about how AIs learn, the importance of the data and the machinery of artificial intelligences, looking at why generative AI systems aren't necessarily appropriate for marking because it's a high-risk activity, and instead classification systems are much more appropriate, and how Grade specifically implements classification-based AI for AI annotations for long-form work. Thank you very much for joining me today, and I hope it was really helpful for everyone. Have a great day, everyone.